So now it's time to report the next step, the multivariate normality and multivariate outliers. I have to say that for structural equation modeling SEM, multivariate normality matters. There are different kinds of checks. We have multivariate, we have bivariate even, and we have univariate normality. Some researchers, as I've seen, they like to report three types of normality. The multivariate, all the models together, the model as a whole should be normal. Or bivariate, from the word bi, you can understand what it means. And then uni, and uni is one. So univariate normality, each factor. But most researchers focus on multivariate and univariate. However, I need to explain that. Why do we need this assumption? We need this assumption because for me, I'm going to use AMIS program. And AMIS program, the best estimation method is the maximum likelihood. There are other estimations method you can use, especially if your data is not normal, meaning most of the data in real world is not normal. You have to clean it a little and polish it before it becomes or exhibits an acceptable behavior close to normality. But you won't find it 100% normal. But there is a tolerance level to deviation away or departing away from normality, or the accepted level of normality. So maximum likelihood is the best, gives the best results. And for using this estimation method on AMIS, then you would need to satisfy two assumptions. Basically, the multivariate normality, and second, you also need to check, but this is regardless actually, you also need to check for influential outliers, so the multivariate outliers. All right, so this is why we are doing this. If you are using any other software like Literal, they do have an estimation method to deal with non-normal data. So the idea is, as a researcher, I am going to start with the maximum likelihood. I'm going to check my normality. If I'm normal, then fine, I'm easygoing. If I'm not normal, I'm going to try bootstrapping. If bootstrapping is not giving me very good results and it's giving me a headache, then I probably have to pay and learn Literal so that I can use the method for non-normal data. So research is not a watershed or a waterfall kind of approach. This step 1, down to step 2, down to step 3, down to step 4. It is more of an investigation and revisiting an iteration of the same step and not giving up. All right. So over here, we're going to focus on the maximum likelihood because it is the most recommended and the bestest method. So what we're going to do right now is to, I'm going to show you how to check for multivariate normality, not the univariate, because univariate, even though most of the research papers are reporting univariate, and over here I am also reporting univariate and multivariate, what we really care about is this multivariate normality in particular. So how do we report multivariate normality? Normality in general is checked through statistically, numerically, through the skewness and the kurtosis of the distribution, of the data distribution. I won't fool you. My data is never going to be normal, and I'm going to be so surprised the moment I read any research paper that they are collecting data from what they call it a Likert scale. I call it an anchored scale. And then I find out that they are giving me, we've done this test and this test and this test, and all of these tests are showing me normality. I would be like, oh, you must have done some cleaning to the data. But I know that sometimes researchers won't tell you everything that they've done in detail. Also, sometimes even with some polishing of the data, is very difficult for any seasoned statistician, not myself, to accept the fact that an ordinal discrete data all of a sudden is treated as normal data. However, in social sciences and management, it is an acceptable practice that we say that we're gonna check the assumptions, and if it's all right, then it's all right. Okay. the first thing that you need to look into is the skewness and the kurtosis. So the skewness and the kurtosis, for normal distribution, skewness should be 0. This is difficult to attain even for continuous data unless the population is too big, and this is like a dream to come true. So there should be a little bit of skewness tolerance or tolerance to skewness. So if the item here is skewed from 3 to -3, this is a tolerated zone for skewness. So acceptable values of skewness fall between -3 and 3. Look at my values. They are within the acceptable. This is the absolute values. Is within the acceptable. Okay. How about the kurtosis? The kurtosis lies between 10 and -10. Look at my values. My values are all right. But again, as I told you, we're not looking at univariate normality. Even if these numbers aren't within the -3 and 3, what we really care about is this number over here, okay, which is at the end of the table, and I'm going to show you how I got these results. There is something called kurtosis over here and also a critical value. This is CR is a critical value associated with each statistics here of skewness and kurtosis. Now, the cutoff value for the critical value, it should be 1.96, below 1.96. Anything above 1.96 is not normal. So according to the CR here, the critical value, this is not normal. And this is absolutely not normal. This is not normal. This is not normal. All of them are above the 1.96 value. These are okay. This is not normal. These are all not normal. And again, the same applies over here. Anything above the 1.96 threshold is not normal. However, based on, this is where I got the reference for the -10 and 10. And also, however, this kind of test, the critical value produced by AMIS, it's a built-in test in AMIS. This, with a bigger data samples, this will naturally leaves us with not normal data, even if it's continuous. So researchers has found out with as the sample get larger and larger, it will be almost impossible to get the critical value within the 1.96 threshold. So that tells us we need to focus on these guys, the skewness and the kurtosis. But remember, why am I doing this? In fact, we are more focused on these guys, the multivariate normality. Why should I look into this? Because again, also with multivariate normality, it is very difficult to get a critical value equal to 1.96. However, as I am researching, I found out this very beautiful reference here that says anything below 7 and 5 here, Benkler, the critical ratio of kurtosis, if it's less than 5, this indicates an acceptable multivariate normality. So if my critical value here for the multivariate here normality is less than 5, then good, I am good to go. This is normal, end of story. I don't understand some research papers who even go through these readings and focus on these readings or focus on other normality tests. Because the assumptions, the main assumption that we're looking for, going after to satisfy, is the multivariate normality. However, I'm just gonna follow their line of research and line of reporting, and it doesn't hurt, it's not gonna bite me. So I'm gonna just keep the table as is, and I'm gonna just report my results. And over here, I'm not happy with the kurtosis. Honestly speaking, I need to share with you the facts. Where? I'm gonna show you here some of the output that I have had prior to that. This is the assessment of normality, for example, before I clean the data. So look at this scary numbers over here. My critical value was almost up to 10. This is before I dropped some of the variables that we were talking about in the previous video. And before I cleaned some of the data points. Look at that. The critical value is 10. We were talking about something less than 5. So for this purpose, what we needed to do, I needed to take a look at my Mahalanobis distance, which is the second assumption. So these assumptions are very much correlated. Let's imagine that this was my data already and without as is, right from the beginning. Then I will just say, oh, lucky me, look, it's less than 5. I'm good to go. I'm just going to go ahead with my analysis. And I'm just going to report it as I reported it over here. I here was going to do something called the Kolmogorov, Smirnov, and Shapiro-Wilk test. Listen, if I am really silly, I will do that. You know why? Because my data is not even continuous, but these are tests for normality for non-parametric tests. I failed these tests. My data failed these tests, and I will show you how to do this in a bit. It's not silly to do it. I'm sorry, I take that back because these are non-parametric tests. They are even, for me, they mean something more than skewness to my data. Mostly my data here, I should be looking at kurtosis for outliers. So I still have some outliers here because I have the multivariant being 13. Should probably for kurtosis stick to 10 or below. So I probably can get this a little bit lower than 5. So you can care about this or you can do both of them together. However, regardless, I've done this test, but this test is univariate normality also. So, you know, it's very confusing how others are reporting their results in the literature. Some researchers keep on reporting the univariate normality, and I don't know why they're doing that. Especially if you're using AMIS, you are aiming at multivariate normality. And this is still confusing to me as a person. So with my students, I'm telling you guys, you just need to focus on this. And as I showed you earlier, these are my original results. I showed it to you just now. And these were my original results before I cleaned the data. So how did I clean the data? Basically, when I looked at the output here, this is the assessment of normality. Oh, perfect. So this is the data. In fact, also, here I cleaned only a couple of points. And no, I think this is the data after I deleted, I think, cognitive trust. Oh, I still have cognitive trust here. So this is a problem here. So I need to delete cognitive trust. This one. Cognitive trust 2, I need to delete that. So you go here. Can I delete this? Yeah. And then run the analysis again. Hopefully it will run nicely and smoothly. Make sure everything is above 0.5. So this is the second checkpoint. Anything below 0.5, you need to tell us that you need to delete that. So this is the first checkpoint, in fact. In this paper, I just ran into the assessment of normality, but even before the assessment of normality, you need to also double check over here your model fit. So it should be not significant, and most importantly over here above 0.95, the CFI, and over here also your IFI is also above 0.9. I have it even above 0.95. This is okay, 0.8 and above, 0.9 and above is good. How about the adjusted here? The adjusted GFI is over 0.8. I have it over 0.9. And the RMC, as I can see here, that is good. It is I will go into explaining these in more details, the thresholds for these. So one thing that you need to look into before you go into the normality check, even though you report the normality before you report the model is that you make sure, or write a sentence that you make sure that all the loadings are over 0.5, say that all the covariance correlations here are below 0.7, actually below 0.5 also, or 0.84 in my case. And also I talked about these should be as low as possible. Anything 0.7, 0.8 or above is alarming, and you should take an action. We're going to talk about this. You just delete that correlation and try to take a look at what is missing or what's happening with your data. Anyway, so after you check the model fit, and I have a video on that, and after you're checking all these loadings on the regression lines and covariance lines and report all of that, you just need to go to the assessment of normality. And this is the table where I got the critical values, and also I got the kurtosis critical values, and then the multivariate. Now what I did is I got to over here, observations farthest from the centroid. This is the second assumption. Second assumption is the multivariate outliers check. And this assumption affects this assumption. Sometimes when you clean your multivariate outliers, you're actually going to clear your normality. Most of the papers in the literature start with the normality check. Why is that so? Because you can't use this estimation method. Again, I'm talking about the likelihood, a maximum likelihood estimation method if the data is not normal. So obviously, these guys and these readings over here can help you get normal data. So over here, as you can see, this is my data before the cleaning, I believe. And over here, I have, these are the distances. And I have the p-value and p2. Usually some researchers say, we clean the data, you clean the data by eliminating all the points that has a significant p1 value. Mostly we focus on the p1. And usually p1 and p2 are related. Once you clean up the p1 value, all the p2s will be cleaned up. Take a look. Over here, the significance level is 0.05. Anything below 0.05 is significant. Over here, this is higher, so this is not significant. So I got all these having a significant value over here. So all these are significant. They need to be deleted. This is one approach, one researcher's approach. Another researcher approach, a person who is more careful, would say, these guys, what is an outlier? It's a distant observation, way from other observations. So all observations are condensed over here, and there's one over there straying away from the density, then this is an outlier or an outlier. So I look at it carefully and with a little bit of finesse. You need to concentrate and focus. First of all, take a look on top. This is the longest distance, 50. Look, 10 points, 10 units between this record 91, and record 103. 10 points. And then the next distance is only 2 points apart. So definitely I am going to get rid of this. Then let's take a look. There's 2 points here, but over here there's 1 point. Over here again 2 points. So, okay, let's take note of this pattern. Over here 1 point. Over here another 2 points. 32, 31, 30, 28, another 2 points. Then 27, 27, 27, 26, 26, 26, 25, 25, 25, 24, 23. They are condensed. They are still in the vicinity of each other up until probably over here. After the 33, I can notice a 2-unit jump. Over here, only 1 unit jump. Can't you see that? 23, 23, 24, 24, 26, 26, 27, 27, 28. Where is 29? There's 29 here is missing also. So you may also tell me, how about 29 here? Where is it? So I will be careful. And I know that every data point, every record here is very precious. So I'm going to probably start by deleting these guys here, then deleting these guys up to 28. then there's 1 unit difference and all is good. I like to do it slowly. You guys, maybe students, just want to get the job done. There's a difference between getting the job done and actually investigating as a researcher. So I would first get rid of this point and come back and revisit it again. Keep this on my Excel and check again the data results, and then go ahead and delete the points that have a very big leap, a jump between them. So there are 2 different schools of thought. Our the school of thought is not just going with the numbers. It's not just the number game. It's some science and art. Not only going with the, if this is not significant, I'm just going to get rid of that and end of story. This is the safeguard. But if I can get everything nicely done, I can improve my results here. First of all, improving my results here. And second, go up there again and make sure everything is getting improved, not getting worsened, and everything is all right. So because sometimes these influential points also might get me worse results. This is oh man, this is quite a discussion and debatable. Third, I will slowly delete in chunks and then see if there's no improvement. If there's no difference, big difference, they are not influential. Why? What is the idea, guys? The idea is to uncover influential points. The point that when I get rid of in the database, in the data, it will give me a huge different results. Let's take a look. So this data, can I change the data? Would it give me an error, for example? I'm getting an error here because I got just my license in ULI. I don't know what I did wrong. They keep on telling me you need to be an administrator and all that. But it's quite interesting that you do your data cleaning very carefully and very nicely and see some of the data may be not influential. The bestest way to improve the readings is to have this as 10 and have this below 5. I got this below 5, but I probably need to work a little bit harder. Yesterday I probably got tired and I just want to get the job done, just like you guys. But now I'm thinking about it. No, this is not how we do it. Probably need to work a little bit harder and get this to 10 or below as kurtosis. However, even if I do all this, okay, I've done this, all is good. I don't think I'm gonna get a nice normality check here for the Kolmogorov and Smirnov test. And in this case, I have to search a little bit farther because I think these checks, normality checks, are not important even, because these are univariate normality and not multivariate normality. If I keep deleting my data and getting rid of my my outliers, sorry, and I can't attain anything below 10, you could probably report your results as is and continue with your analysis, and that would be acceptable to me because it is below. What's important here is that it is below 5, as we have it here from this reference. It is below 5. But if you can get it here below 10 with acceptable left data points, I don't want you to delete all your data, half of your data set. This is also not acceptable. You can delete up to 5% to 10% maximum of your data points. More than that is too much really. So if you are collecting 200 data points, probably 200, I'd rather see something like 220, 223. Always collect a little bit of a data points that is almost 10% of the 200, so that you can get rid of outliers and not end up having a data set of 150 because you removed so much outliers, and this probably gonna affect these readings also. So you need to rerun this again with the clean data. So this is why most of the researchers find exploratory factor analysis to be very confusing, super confusing, because these results, in fact, sensitive, but not highly sensitive, but may change based on this outlier check. And this outlier check should be also will affect the normality check. So do you see the intertwined relationships here? All right, so now let's say scenario 1, you have this higher, you just delete the outliers based on the Mahalanobis distance. Most of the time, if you have it, you've done your job correctly, as I did it, you will be able to reduce that critical value to an acceptable level. If you couldn't, then no problem. You will just say, I couldn't, I don't have the multivariate, then you can contact me and we'll see what we do from there. Because if you don't have the multivariate normality, it is very difficult for you to use the maximum likelihood estimation technique. It's very difficult to use it. Unless we're gonna just use it for you admit it and you show that you know what you're doing, but you are already on trial for AMIS, so it's all right. If you haven't had it, just contact me. We'll see what to do. I would have to use another software called Lizerol, and with the Lizerol, you can use the non-normal data. So multivariate normality is not a must, and you don't have to go through this pain. But you will still need to check for multivariate outliers, influential points, and get rid of them because they might improve or even the results over here as we've seen earlier. Okay. Now, in some researchers, they keep on reporting these tests. These tests, you get them from linear regression from SPSS, I think, is it? I think you go to a regression here, and you go to linear, and then basically you can put your numbered here. This the first line, which is the serial number, you can put it as the dependent variable for the sake of this analysis, for this purpose, as a dependent variable. It doesn't matter. I think what I'm doing right now is multicollinearity. There are also some researchers, because what we're doing is nothing but internally linear regression. You also need to show the multicollinearity check. Anything else that I need to do, if I remember, and then hit OK. And over here, you will be able to get the VI. I'm sorry, I didn't check multicollinearity. I am supposed to go for regression, linear, and multicollinearity. Let me check where I get the multicollinearity. Should be somewhere here. Yeah, here it is. So over here, it will give me the VIF value, which is the variance factor here. So the VIF should be less than 3. Is very good. Less than 3 is super very good. About 5 is moderate. Multicollinearity. Multicollinearity is that they are very highly correlated to one another. And below 10, some people say it's acceptable, but it could be weak. I am kind of lucky because most of my values below 3. I only have these 2 values around 3, but all my values are below 3. So with my below 5, and these are around 3. So with multicollinearity, I can just say the VIF is below 5, and it's okay. Like most of it is below 3. I have only 2 values below 5. If I can get rid of these, get rid of them. So for example, I could say 3.2 can't be rounded can be rounded to 3. So it is a 3 and below is okay. even though up to 3, they say it should be lower than 3. So you can't really play around it. So I have these two. I probably have to consider getting rid of one of them. So I might have to get rid of one of them. Probably I should look into this one here and see which one loads higher. And both of them are loading very high. And here the follow loading 0.9, but the likes. So follow is to follow the brand page. I could get rid of that in my research. I could just not take the following a page and report results on following a page, and I can just leave the analysis with the likes and see how this is like. Let's double check that. For example, let's see if I get rid of one of them, probably the other will be lowered. So the number of follows, let me just, do you see the logic here? So over here, for example, I'm gonna get rid of the number of followers on the page of the brand and take a look and see what happens. Let's focus on the VIF. And now, as you can see, this is what I'm talking about. I don't have anything above 3. Do you guys see that? So this is another elimination method. But probably I don't have to report that in my journal paper. I will just write from the beginning, not talk about following the brand page. You see that? But in your thesis, it's good to show all the hard work that you've done to improve your data and get no multicollinearity data, because this is an assumption for linear regression. It has nothing to do. Multicollinearity is an assumption for an heteroscedasticity or heteroscedasticity. There's also another assumption that has nothing to do with the normality per se, but with the linear regression that you're using deep inside. All these lines are linear regression lines, and these are covariance, yeah? So there are assumptions for linear regression that you took in stat course and in different analytics courses, and one of them is multicollinearity. So you need to meet the multicollinearity test. So over here, I think I'm gonna have to let go of one of my crowd engagements, and I will still have 1, 2, 3, 4, 5. Oh, I have non-trusted friends here and negative comments. Probably if I get rid of these, oh, I'm sorry. Anyway, this is something I will do later at my own time, but be careful. Make sure that you always get rid of the variables that you don't need to see. Here, negative comment, put back. I don't need that, I don't need that. And cognitive trust, if you guys remember, we also got rid of that, and then run the analysis again. Who knows, you might get all of them below 3. You see, I don't have to delete the follow. I don't have to delete the follow. Did I delete that? I already deleted it, maybe. Yeah, I already deleted one. But I just made a mistake earlier of not deleting the other ones that I was supposed to delete. So over here, I'm gonna put it back and see if things getting better. No, things are not getting better. So when I put the follow, again, it is over 3, and also likes is over 3. So this is why I have to get rid of one of them, which is here. I'm gonna get rid with this one. First of all, it has the highest VIF value, and also to my research, I can just focus on advertisements, and this is not following an advertisement, this is following the brand page. I can just not talk about following the brand page. So this is also another checkpoint that you could eliminate some variables or items from. So my advice is to start with the multicollinear, the normality, multivariate normality check. Focus on this rather than focusing on the critical value, because you can say that these are very sensitive and they almost always over 1.96 when the sample is very large. And you can instead also, and within this table, report the VIF values. You can put before elimination and also add here after elimination. And you can clearly show that you eliminated one of these variables, which is this one, I think, that we trying to eliminate, or either one here that you're trying to eliminate, so that you can improve your results. Okay, and this is a well-known practice in linear regression also, that we eliminate the variables that exhibits very unacceptable VIF value. If you want to be very strict, some researchers are very strict. They say less than 3 as a VIF value. Some researchers get away with 5, so they accept a strong to medium. I would say as a student, if you end up with less than 3 items loading in one construct, I accept 5 as a VIF. Or in the future, when you are using AMIST for analysis and your results are, your model is not building right, or you are facing some trouble, keep in mind that, you know what, I could just put this back and see what happens. If you put it back and see that your analysis are better, then keep it and say I accept anything below VIF below 5, and I will accept that. Especially if I ask you in the presentation why and what, and you can answer all of that. So you need to have a reason. So for me, I'm very flexible. I would rather have anything below 3 myself if I could. Over here I could, because I have values over here, the items the items being over 3 remaining. However, I am not gonna stress you out, but below 5 is also acceptable. Okay, what else? This kind of test, I don't know why researchers keep, I looked into 1 or 2 research papers, and they keep telling us that these tests are okay. These tests in particular, the Kolmogorov Smirnov test, this is for smaller samples. This is for bigger samples, so we do both of them anyway. And they should be both insignificant. If they are significant, you are in trouble. So you don't want to reject the null hypothesis. You want it to be insignificant. So you want these values to be less than greater than, you want the significance to be greater than 0.05. And in my analysis, I failed to show that these are greater than 0.05. My confusion here is, why do I need to check these tests for normality, for univariate normality, when the only assumption needed for maximum likelihood is the multivariate normality? And these tests, I'm gonna check again if they are another way of checking the normality of the error. Because in regression analysis, we check the following assumptions. We don't check the normality of the variables per se in regression analysis. We check the normality of the errors. We check multicollinearity, and over here, and we check what is called heteroskedasticity. I'm gonna have another video, maybe this video is getting too long and I haven't got to this part yet actually, where I'm checking the heteroskedasticity also. But usually heteroskedasticity is more observed in continuous data, but who knows? In fact, if the data looks, it's more into, maybe it's more into continuous data, heteroskedasticity, or homoskedasticity assumption it is. And heteroskedasticity is the thing that we don't want to see as a behavior in the data. In any case, with this kind of data, maybe multicollinearity is all right. VIF multicollinearity check, And I'm gonna just focus on multivariate normality, which is this over here. If you can lower the kurtosis to 10 and keep this below 5, okay. If you can't lower this to 10 because you are afraid you're gonna delete so many points and this is below 5, I accept it, it's okay. If you reference the right reference over here, all is good. Now, the second check, I want to see this. I want to see it to fatten up your thesis. But if these are 1.96, good, talk about it. If they are not 1.96, don't worry, because univariate normality is not a must, is not required. Only this one, the multivariate normality. Now, some researchers also, they say it's up to 1.96. Others say with bigger samples, it's very difficult to attain the 1.96. So we're going to end up with less than 4 and less than 5, and I have the reference. In this case, this is also checked, and you are good to go. Now, for this, if not, and then it checked the multivariate outliers, and this is through AMIS, and you can go to the Mahalanobis distance and find out if there are big leaps. If there's a big leap like that, delete the first one and see what happens. If it's influential, this value over here will drop dramatically, which is good for you. Then with if this value is acceptable to you already, good. If your value is 2 and you think you can lower it to 1.96, so it is less refutable by others. Some researchers might say, where did you get this from? Who is this person? I've never heard of him. This Bentler. Who's this Bentler? This is very old. It's 2006. This might also be problematic. Yeah, this is also might be problematic. They tell you, oh, I never heard of this person. Who is this Bentler? Let me check his paper. How many people are citing his paper? And so on. So this might be refutable for us when we want to publish your work or go on a conference or so. Some people might tell you, where did you get this from? In this case, you can also very much investigate the multivariate outliers. Okay, good. I hope that I was clear. As for me, I still in doubt that we need this because this is for indicators. So I don't need this really, but I kept it here just for the purpose of this video. For the Mahalanobis distance, I wrote that we delete them with respect to P1 and P2 values in AMIS, but honestly, I don't like this approach. I like the more careful approach where you see, are they really influential or not? Because this is the reason why we are deleting them. If I delete them this and nothing happens really, the value, the multivariate here value over here doesn't change much, then it's not very influential. So there's no need for me, it's not distracting my analysis. So there's no need for me to necessarily drop it. This is the kind of person who just learns things by the book, but not by understanding it. So be careful with that. If you have so many data points, if I had so many data points, to tell you the truth, if I had so many data points, I would probably do that. But let me explain something. If you are a seasoned researcher, what's going to happen is you're going to delete the first data points that the top data points that causing you trouble, for example, or showing you a tremendous improvement here. And then what happens, you will have a newer list of values, and then you keep on deleting. Even if you deleted all these values at once, check it again, you will have still other values with a p-value less than 0.05. It's a never-ending process. You probably not, let me say it again. Nora decided to delete all of these because she has so many data points. So she said, all right, I can get rid of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I have 20, 25. I can get rid of 20 points and I end up with 205. So I have about 200 points. Good. I can do that. I can afford that. I still have 200 points for my research. Good. And this is kind of threshold for all SEM research, at least 200 points. So I tell my students always collect more than 200 points so that we can afford getting rid of some influential points. All right. Then if I ran the analysis again and look at the Mahalanobis distance on the new data set that is not 2025 points but 205, what's going to happen is, again, a couple of the top records here, points on this list will still have, most likely, a couple of them will still have a significant p-value on top. And then what does that mean? I'm going to delete it again. I'm going to delete again. I'm going to delete again. You're going to end up with no data left. So please use your beautiful brain. It is a combination of this along with this, the big jumps here, all right? So this is the kind of things that you might get confused with if you are watching videos of other researchers on the internet or people who are still learning. I myself telling you for sure, please, if you can afford it and you want to do it, do it. And if you have good results and everything is all right, good. Next time you want to delete, you look at the Mahalanobis distance and you thinking, oh, these are all again non-significant, try to take a note of this over here and see how much improvement are you getting if you're deleting more data points. You might not get any improvement, or you might get a very, very, very small improvement. That is not worth it to delete more data points. And these are not very influential data points because when you deleted them, not much happened. Okay, now I'm repeating myself again and again. I think I should just let you go right now. Hopefully I will summarize everything. Multivariate normality. Some researchers report multivariate, univariate, and even some do the bivariate. It depends on whether you are doing a partial least square or you're doing SEM based on correlation and not causal relationship, but rather correlations. In this case, the assumption, the reason for the assumption stems out from the fact that you are using the maximum likelihood estimation. Using the maximum likelihood estimation, you need the multivariate normality. All this doesn't mean anything personally to me, this up to here, because these are univariate normality. You want to show me the results? Please do. Please show me the results anyway, but this is not a deal breaker. You can still, if you want, you can just make sure in terms of outliers to take a look at the kurtosis, and it's between 10 and minus 10, as you can see here. And this is between 3 and minus 3. But even if they are not, it's not a horrible deal breaker. And then you need to take a look at this. For me, it was above 5. Some researchers go as far as 1.96. In this case, for example, if we write our analysis and write our paper and the editor says rejection, it is less than 1.96, we can put it into another journal, or we can use bootstrapping right from the beginning so the paper doesn't get rejected. And this is what I will do, because I'm not sure if I'm going to submit this paper to the same journal where I saw multiple papers getting away with critical value less than 5. Oh yeah, sure, I will do it. And I will submit to the same journal, and hopefully I will have better chances of just using the maximum likelihood of AMIS without what we call it bootstrapping. Here, there's something called bootstrapping, and you might need to use it if your data does not exhibit very good normality. All right. Next, you need to check the VIF. As I showed you here, I have a problem here. I might have to get rid of one of my data points, but before that, maybe I improve this kurtosis a little bit and drop it to 10 or below 10, and this will drop accordingly. And hopefully maybe this will be improved. I'm not sure. So I always double check and go back again and take a look. Once I'm done with all this, the VIF, and there's also the heteroskedasticity. The heteroskedasticity assumption, you also need to check that. And these VIF and heteroskedasticity assumption are assumptions necessary for the regression analysis, yeah, not for normality. This is not a normality check. Univariate and multivariate normality tests normality and multicollinearity tests, I would call it, or normality, multicollinearity, and heteroscedasticity test. And over here, if you have VIF before elimination and VIF after elimination, if that is a reason for you to eliminate a variable. As for me, I would like to see before and after in your thesis, so it will show that you've done the work and you know what you're doing. In our paper that I'm going to write for us, we are going to just start the analysis right from the beginning with no variable like that, because then it will be so much of a distraction. Or you can just keep it there, it's not a big deal. All right, anything else that I'm missing on? The Mahalanobis distance is nothing but getting rid of influential points in the data set. If deleting the Mahalanobis distance, I suggest and recommend using your beautiful brain and not randomly just deleting all these guys because they are below the significance value. Because again, if you check again after deleting these first set of data, you will find out the top values again will have a significant value, most likely, but not all the time, but most likely will have a significant value, and then you will have to delete them and again and again and again. It's a never ending circle or cycle, sorry. So what you need to do is make sure that the deletion, in fact, influential, affects the results here. Okay, goodbye for now. I'll see you in the next video.